Okay, so I am recording this and I'll post it up later today. But essentially today is, let me, uh, second here. All right, give me 1 second, sorry. All right, let me share my screen. All right, here we go. All right, so yeah, so apologies for not making it in person. If you saw, the announcements that I put, I got sick over the Thanksgiving break, which means that I had to quarantine at home, and so that's why I wasn't there last week. And so that's why we're having a Zoom session today. Today is the last day that I need to quarantine. After today, I am free to go back on campus. So today is December 6th, and we're just going to be reviewing. We're going to be going over problems. Um, you can ask for whatever problems you'd like to see solutions for, and we can talk about the material a little bit. And so today's a review. Next time I see you in person, in our usual classroom will be on Thursday. I'll be there, and I will hand out exam number 3, which is going to be very similar to exam number 2 or exam number 1 in the structure, but it's going to cover material from worksheet 6 and worksheet 5. And so I got a question here in the chat saying, will this final exam cover everything we have learned? And the answer is no. Exam number 3 is not even technically a final exam. It is the last exam that we'll have in this class, but it's going to be weighted exactly the same as exam number 2 and exam number 1. So exam number 3, just think of it as just the next exam. Just like exam 2 was an exam and exam 1 was an exam. Exam 3 is just another exam. It's the last one, but it's not really it's not going to be a comprehensive final. It's going to stick to the material on worksheet 6 and the material on worksheet 5. And that's for the in-class portion of the exam. As usual, in-class portion covers the stuff that we went over in class. There will also be an online portion of the exam, just like there was for the last 2 exams. And that one will cover module 3A and 3B, so the stuff that you worked on. And so just to mention a little bit more on that, there was an announcement put out by David Hambly on the 28th of November. And this announcement, we've already read it 2 times before for exam 1 and exam 2. It's basically the same thing. So there are 3 parts to the exam. The first part is the integrity affirmation, just saying you're not going to cheat and you're going to, take the test. But the ALEKS portion is going to be available between 8 a.m. and 10 p.m. I strongly recommend that you, I would say try to have this done by the time you get to class on Thursday. But if you want to do it after class, that's fine as well. Just as long as you don't forget. Um, as usual, you'll have 70 minutes on this exam. There are practice problems, which I'll pull up today, and we can work on those. And then we'll also have the in-class portion of the exam. Just like before, it'll be like a double quiz based on worksheets 5 and 6. 40 minutes will be given for that. So basically the entire class time. Yeah, but just the usual stuff, you don't have any calculators to use on the exam. I will provide the unit circle on the exam. And then for the online portion, you can use blank scratch paper, and then there's a reference sheet that has a couple of formulas that you could use in case they're necessary, and then the unit circle as well. Okay, so yes, which worksheets will be on the exam? Somebody's asking in the chat, and it's in all of the information is right here. It is worksheets 5 and 6, right? It's here in the announcement. Feel free, actually, I recommend that you go through this if you don't remember, all the details of the exam. Run through this announcement. It was put out on November 28th, and so you can find it under announcements. Okay, so good. Any questions about the exam on Thursday? And if you come up with a question throughout today's discussion, just put it in the chat, and I'll try to see that and answer it. Okay, so So then that means that we should be reviewing today worksheets 5 and 6, and then the Alex practice problems. And somebody else asked, is this the last week of class? And yes, that is true. Today is basically the last day that I'll be talking for the most part during the class. And then next time we meet is our last meeting, and there will just be an exam. So it'll be exam number 3. That we kind of just went over the details about it, but that will be our last meeting. We do not meet the next week after that. There technically is not a final exam, specifically a final exam for this class. There are just 3 exams, and we've already taken 2 of them. The next one is on Thursday. Okay, so the answer to your question is yes. This is, excuse me, the last week of class. All right, good. Yeah, no problem. So let's go ahead and close that. We'll switch back over to, oh, I need to open up. Let's close that. Close that. I need to open the iPad. Mm-hmm. All right. So just to kind of give us an idea of what kind of problems are on this worksheet, or these practice problems for Alex, I'll do one of the ones on here. Then I'm going to switch over to one of the worksheets. And then, if anybody types in a problem number or, on the, in the chat, then I'll do that next. Okay. So at any point, feel free to, to just type in. I'm going to choose problem number 5 on this Alex worksheet here, because it's very similar to stuff that we did in the worksheets. And so it's kind of nice. So question 5 says, suppose that the point x comma y, right, the y value is given, is a point lying in quadrant 2 on the unit circle. Find x. And then we want to write the exact value, not a decimal approximation. Okay. So this is x and y, and then quadrant 1 and quadrant 2. We're interested in quadrant 2 here. So there's a point here, I'll just write it right here, somewhere in quadrant 2. We don't know what the x value is. We know the value is square root 5 over 5. So what do we know about the x value? Can somebody tell us? The y value represents this height. What do we know about the x value? It's negative. Good. Yes, so when we calculate what x is, we're going to calculate a value, and hopefully it comes out negative. Now, what about the length of the hypotenuse there? What is that equal to? So we have a right triangle here that I've drawn. What is the length of the hypotenuse of this triangle? Yes, I can see a few people saying 1. That's true, because we are told that we're on the unit circle. And if you were to draw that circle, the unit circle, it would have a radius of 1, right? So I'll delete that circle, but yes. And now we can see that there's a triangle. We have 2 of the side lengths, and the third one is unknown. So we can use the Pythagorean theorem, x squared plus y squared equals r squared. And so x is unknown, y is known, and r is 1. So we can just square the square root of 5. That's 5 over 25 equals 1 squared is just 1. I'm going to write 1 as 1 over 1 and get a common denominator of 25, because we're going to have to combine those 2 fractions. So if we subtract 5/25, then we get x squared equals 25/25 minus 5/25 is 20/25. And then if we take the square root of both sides, officially there's a plus or minus, but which, of those 2 values do we want? The positive or the negative? Yeah, good. Negative, because we're in quadrant 2 and x value should be negative. So x is equal to negative, and I'll write it as the square root of 20 over the square root of 25. We know what the square root of 25 is. That's just 5. The square root of 20 Can anybody tell us what that simplifies to? The square root of 20 simplifies to 2 square root of 5. Very good. Yeah, and just to show a little bit of work, in case anybody's wondering where that came from, the square root of 20 is the same as the square root of 4 times the square root of 5, and we all know that the square root of 4 is 2. So here is the x value. And that is our answer. Yeah, we were asked to find x, write the exact value, not a decimal approximation. So there it is. Okay, so after this problem here, I would like to go to another problem in worksheet 6 because I was gone last week. I think you guys had a somebody filled in for me. But that means that I didn't really get to go over this material, with you all. And so I would like to talk a little bit about these inverse trig functions. I forgot who filled in, but yeah, I also posted videos on YouTube, and hopefully, did anybody happen to watch those videos? There was a couple posted. Yeah. Okay, cool. Yeah, so a couple people said that they watched them. Nice. So, yeah, so we'll just do a couple problems here just to kind of get us warmed up. And then again, remember, if you say, hey, I want to see 8b or whatever, type it into the chat and we can work out these problems. All right, so, okay, yeah, so there's a question here in the chat. Could we leave the answer as the square root of 20 over 5? Or do we have to simplify it how we simplified it to 2 square root of 5 over 5? The reason I simplified it, I did say, for an in-class quiz or exam, you could leave it as the square root of 20 over 5. But for Alex, since that was an Alex problem, Alex does say to simplify. So on the Alex exam, you do want to simplify to make sure that you don't get marked off. So, in a sense, the answer is both of those. On Alex, you want to simplify all the way. And then on our in-class exam, it's up to you. If you don't simplify it all the way, that would be fine. But I do believe that Alex will mark you wrong unless you simplify it all the way. So this is the preferred answer on Alex. That's why I wrote it that way, because these are the Alex practice problems. Okay, so all right. So let's go ahead and take a look at a couple of these problems. We'll do maybe one for each trig function. And so the cosine inverse of 0, this inverse function, it actually, the output is going to be, the answer is an angle. So we need to try to find the angle. Excuse me. This angle is going to be in the range of the cosine inverse function. All of this stuff was covered in the video. And the range of the inverse cosine function is 0 to pi. Okay, so the answer is an angle, and I'll call this angle theta. I always try to put a little name for the angle. Theta in 0 to pi, with the cosine of this angle theta equal to this value here, that's the input, equal to 0. So basically, we need to go to the unit circle, and let me go ahead and pull up that unit circle. Worksheet 6. So 0 to pi, we should remember 0 pi over 2 pi. That's these two quadrants here, quadrants 1 and quadrant 2. So on the unit circle, we should be checking these two quadrants. Is there an angle in one of these two quadrants where the cosine of that angle is equal to 0? Can anybody tell us which angle has a cosine of 0? Very good. Yes, that's correct. Pi over 2. Remember that the cosine is given by just the x coordinate. So really another way I could have worded that is just, which of these points has an x value of 0? And that would be pi over 2. Now, I'm happy that that came up as well. So the answer here, theta, is equal to pi over 2. Now, not to pick on you here, but 3 pi over 2 is actually not a solution to this equation here. 3 pi over 2, if we look at that angle, the x value is 0. So that is true. It is a potential maybe answer, but we do have to, it's very important that we look at the domain, or sorry, the range of cosine inverse. And we said that the range is from 0 to pi. So that corresponds to all angles in quadrants 1 and 2, or through these angles 0 and pi. And that means we should not look in any other quadrants or down below for cosine inverse. Okay, so just a little remark there, because it is tempting to give 3 pi over 2 as an answer, but there is only one answer to this question here, and it is pi over 2. Yeah, and there is no other answer. So just be careful there. Okay, so good. That's it. Yeah, that's it for that problem. Now let's take a look at, let's do one more here with cosine, because we're still looking, I gave a lot of background information here just to kind of get us, make sure that we're all up to speed. But these problems, at least these here in part D, it is simple enough where you don't really have to write anything down except for the answer. What is the cosine inverse of -1/2? And it basically comes down to, like I said, which of these angles here in the top two quadrants has an x value of -1/2? Let's give everybody, 15 seconds to think about it. Yeah, and so up here, which angle has an x value of -1/2? And yep, 3 people have already mentioned the correct answer there. It is 2 pi over 3. Very good. So the answer here is 2 pi over 3. So hopefully you're thinking, yeah, that's not too bad. Yeah, that was pretty easy to solve in a sense, as long as you know the background information, the which quadrants you're looking at. So let's take a look at sine, because sine is has a different range. So the sine inverse of √3 over 2 is, an angle. So again, this, I can't really stress this enough, this inverse function represents an angle theta in, what's the range of sine inverse? Does anybody remember that? A lot of people are answering here in the chat, so that's good. What's the range of sine inverse? And feel free to use your microphone as well. You're welcome to do that. Okay, yeah, and we got a correct answer there. Negative pi over 2, 2 pi over 2. And then, so we're looking for an angle in this region, negative pi over 2 to pi over 2, where the sine of that angle in question is the square root of 3 over 2. And so that means, I always like to draw the picture here. Negative pi over 2 is, if this is 0, and then we know this is pi over 2, we should know this one by heart here. But negative pi over 2 is just in the clockwise direction there. And so we're looking at quadrants 1 and 4 now. Excuse me. And so can you find an angle whose sine is square root 3 over 2 in quadrants 1 and 4? Can somebody tell us? I'll wait for a couple of responses. Getting a couple different answers here. It is the angle. The answer is pi over 3. Yes, positive pi over 3. and I'll point to the cursor here, the sine, we want the sine to be square root 3 over 2. So that's the y coordinate. We want the y coordinate to be square root 3 over 2, and that occurs here at pi over 3. I got some pi over 6s. You were still thinking about the cosine, I think. Yes, I can see why you would choose pi over 6, but that's the x coordinate. That represents cosine. So we want sine to be square root 3 over 2. That means that the y value has to be square root 3 over 2. That's pi over 3. And I got a couple answers over here down in the negative direction as well. But actually, it can't be in the fourth quadrant because sine, notice all the sine values, all the y values are negative. And we want the sine to be positive, square root 3 over 2. Okay, so hopefully that's okay there. Very good. And then, excuse me, we'll do just one more of these. How about the tangent inverse of the square root of 3? So this is very similar. This, represents an angle theta in the range of tangent inverse is very similar to the range of sine inverse, except it's just not including the boundaries, the endpoints. That's not a huge deal. In negative pi over 2 and pi over 2, we want the tangent of this angle theta to be equal to the square root of 3. Okay, and you can think of this as a square root of 3 over 1, or however you want to think of that. But we're still looking at quadrants 1 and 4, right? This is the same quadrants as sine, essentially. Yeah. And so, which angle has a tangent of square root 3 over 1? And remember, tangent was defined as y over x, opposite over adjacent. And the opposite side was y, the adjacent side was x. So which angle would this be? And let's see here. We'll give a little bit of time here for people to respond. Okay. So what is the answer? Well, it turns out it is pi over 3, because let's double check here. For pi over 3, if we take the y value, square root 3 over 2, divided by the x value, 1/2, this is square root 3 over 2 times 2 over 1. If the 2's cancel, then we get square root 3 over 1, or just the square root of 3. And so that means that theta, the angle in question is pi over 3. All right. So that one there, you got to do a little bit of mental division there, but not too bad. Okay. Any questions there? Are there any other questions, that you'd like to see? Let's see. Here's a question. What if we get 7 pi over 4 as an answer for an inverse sine question? Would the answer stay as 7 pi over 4, or would it be negative pi over 4? Good question there. That is a good question, and we can the answer is that it would be negative pi over 4. And I can give an example of that here with part E, if we want to see one more of these. Nobody has really asked any questions in the chat yet with a specific question, so I'll just do one more of these just to answer your question as well. So yeah, a good question there is for sine inverse. Remember, we said that this is an angle theta in negative pi over 2 to pi over 2. With the sine of that angle theta equal to negative 1/2, right? I'm doing part E here. Okay, so negative pi over 2 0, and pi over 2. So quadrant 1 and 4. Can we find an angle in these two quadrants where the sine or the y value is -1/2? What do we see in the unit circle here? -1/2. What is our answer? What angle has a sine of -1/2? All right, very good. It is 11 pi over 6. Yeah, so if we look at the unit circle, 11 pi over 6 is what we get from the unit circle. Definitely the sine of 11 pi over 6 is equal to -1/2. But is 11 pi over 6, let's see here, I'm trying to, is 11 pi over 6 in this interval here? Is it between -pi over 2 and +pi over 2? The answer is no. So yeah, so we can amend that a little bit, because if you think about 11 pi over 6, 11 pi over 6, looking at it on this unit circle, the way that you would get to it in standard position is you would rotate all the way around here to get to this angle here of 11 pi over 6. That's a lot of rotation. That's actually rotation past pi over 2, right? That's past 90 degrees. And so the other way that you could get to this angle is by rotating in this direction. And so you would say, how much do you have to rotate in the clockwise direction? And the answer is -pi over 6. Now, if you don't see that, you could also say, well, 11 pi over 6 is too big. So we talked about coterminal angles in this class. We can find coterminal angles. If this is too large, then we can subtract 1 full revolution of 2 pi over 1, get a common denominator, and so we get 11 pi over 6 minus 12 pi over 6, and this is -pi over 6. So our answer is -pi over 6. Very important that we get an answer that is inside of this range here. Okay. So the answer is -pi over 6. 11 pi over 6 is definitely a step in the right direction. So it's not like, that was just, it's used to find our answer. So you do have to be a little bit careful and know the range of, that inverse function. So does that answer your question, Edwin? Okay, yeah, no problem. All right, very good. So let's step it up a notch then, and let's go to, just another problem. Still, oh, here we go. Yeah, nice. Somebody said, can you do 5A on worksheet 6? Oh, sure. Yeah, I actually would prefer if you all, kind of ask questions and lead the class in this way. So 5A on worksheet 6. So for this problem here, you really need to know the basic tangent function. So I'll graph it here very quickly. And again, this was on the video that I posted. And we also did this on the day that the last day I was there. The tangent function, it looks like this. -pi over 2, -pi over 4, 0, pi over 4, and pi over 2 are the important, 5 x values. For each of these trig functions, 5 x values are the important ones. Now, what occurs at each of these? We have vertical asymptotes at -pi over 2 and +pi over 2. The value of the tangent function at pi over 4 and -pi over 4 is either -1 or +1. It's at -pi over 4, it's -1, and at 0, it's 0. And so the function looks like this. Okay, so this is the basic, this is the one we have to know well. The parent function is what it's called. And then we also talked about, well, how do you find let's say given f of x equals a tangent of bx, a will stretch or compress vertically, and b will change, it'll stretch or compress horizontally, excuse me, horizontally, and the period is found by just taking the period of tangent, which is pi, and dividing by b. Okay, so that means that the period of the function that we're working with here in this problem, 5a, the period is going to be pi divided by 1/2. And we can divide by pi by 1/2 by multiplying by the reciprocal. The period for this one is, it actually turns out to be 2 pi. And so since the period is 2 pi, we talked about something in our class, that I used. I called it the, horizontal increment. And this is what I use to label the x-axis. This is always just going to be the period divided by 4. So that is 2 pi divided by 4. The period of this function is 2 pi. We divide it by 4, and this gives us pi over 2 after reducing by 2. So pi over 2 is the increment that we're going to use on the horizontal axis. So I'm going to use 2 tick marks here to draw pi over 2. And then 2 tick marks again for another pi over 2. That would give us 2 pi over 2, which is just pi. And then we know that tangent also goes to the left of the origin. So we should go to the left here and mark negative pi over 2. And then another increment of pi over 2 in the negative direction puts us at negative pi. And so knowing this, we have the basic structure now of this graph. There are asymptotes here at the end, on both ends. Now, what's going to happen to these 2 points here that have a y value of 1 if there's this 3 in front of the tangent function? This is, they call it a vertical stretch, vs here. So these y values are just going to get multiplied by a factor of 3. So 1, 2, 3. In the negative direction, I'll mark a negative 3. 1, 2, 3. In the positive direction, I'll mark positive 3. And so we get the point negative pi over 2. I'll make it nice and big, comma, negative 3. 0, 0. And pi over 2, comma 3. And this is what we get. That is our graph. Not a super smooth curve. These are a little bit hard to draw because they're very elongated. But as long as you got the basic shape, that's good there. Okay, does that help there? Yeah, no problem. And actually, I do want to graph this on Desmos real quick, just to compare it to the basic tangent graph. Here's the tangent of x, and then 3 tangent of 1/2 x. Just to compare 2 of these. Yeah, so notice yeah, the blue graph is it's a little bit hard to see actually, but x equals pi. Yeah, so you can see the blue graph. That's the one that we graphed. It does follow. It is between negative pi and positive pi. You can see that there in the graph. And then if you put the original tangent function, yeah, you can kind of see that it's slightly yeah. I mean, yeah, maybe it's a little hard to see because of the scaling, but um, this is our graph between negative pi and pi. All right. Any other questions? What else do we have? So I was actually moving on to problem number 7, just to take a look at this one. Now, yeah, I mean, yeah, why not? Let's take a look at problem number 7. Yeah, and so let's take a look at this one. This one's not too bad, actually. If you can see my entire screen, then the cosine of 11 pi over 6, this is the cosine of an angle, right? And we're going to get a ratio from this, adjacent divided by hypotenuse. Can somebody tell us what the cosine of 11 pi over 6 is? It's on the unit circle. So we can see the answer there. Square root 3 over 2 is correct. Yep. 11 pi over 6 is right there. The cosine is the x value, x over r officially, but r is 1, so x. And so we get square root 3 over 2. And now we want to find the cosine inverse of square root 3 over 2. So now we want to find an angle. Remember that the range of this is, so the output here should be in the interval from 0 to pi. So now in quadrants 1 and 2, can you, oh, and it's kind of off the screen there. In quadrants 1 and 2, can you find an angle whose cosine is square root 3 over 2? Yes, very good. A lot of people are chiming in there. Pi over 6. I notice, yeah, so that didn't take too much work, right? It's right there. Pi over 6 has square root 3 over 2. So notice how this kind of flips around. The cosine of an angle is a ratio, adjacent divided by hypotenuse. The inverse cosine of a ratio is an angle, right? And so the answer is an angle here. Good. The output of any inverse trig function, yeah, is an angle. Oops. And that's the angle, that's it. And so just keep in mind, notice that 11 pi over 6 would not have been the answer because that's not in the range of cosine inverse. Sometimes students will say, well, cosine inverse and cosine are inverse functions, so they should just cancel, and the answer is 11 pi over 6. But we can see that that's false. You really do have to go step by step. That is true in certain conditions, but we can see here clearly that the answer was not 11 pi over 6. All right, good. So let's do one more of these inverse ones before we move on to one of these equations and finish. So the arctangent. Now this is I like this problem here because, just like we said earlier, just a moment ago, the inverse cosine function gives us an angle, right? Keep that in mind. The same thing is going to happen here. In the previous problem, we were actually able to find what angle that was. In this problem here, problem 8a, we don't actually end up finding out what value the angle has, but we can kind of describe the angle a bit. So the arctangent of square root of 5 over 2 remember is an angle let's call it theta, in the interval from negative pi over 2 to pi over 2, where the tangent of this angle theta is equal to the square root of 5 over 2. So if we go to look at negative pi over 2 to pi over 2, somewhere in here, there's an angle whose tangent is square root of 5 over 2. It actually has to be in quadrant 1. This angle, theta, needs to be in quadrant 1 because, well, let's try it. Let's just draw it in quadrant 1. Let's assign the opposite over adjacent side lengths, right? Opposite over adjacent, square root of 5 over 2, since it's tangent. If we had tried this in quadrant 4, it wouldn't really have made sense because the opposite side length would have to be negative, or the opposite, it goes in the negative direction, and there is no negative here. The adjacent would still have to be positive because the x direction goes in the positive direction to the right, so it can't be in quadrant 4. So that's why I drew it in quadrant 1. Now we've drawn the angle. It's some angle in quadrant 1. I don't know what angle it is. I don't actually know the value of the angle, but I don't have to know the value of the angle because all I'm asked for is to find the sine of that angle theta. And how do we find the sine? We take the opposite side and divide it by the hypotenuse. So we could solve for the hypotenuse. Let's just call it r for now. Using the Pythagorean theorem, x squared plus y squared equals r squared. 4 plus 5 equals r squared equals 9. And so r is equal to positive 3. We've said in the past that r has to be positive. R can't be negative. So r is equal to 3. And therefore the sine of that angle theta is equal to opposite over hypotenuse. This is our answer here. So I like this problem because there's an arctangent whose output is an angle, but we actually never figure out what that angle is. I have no idea what the measure of that angle is. It could be, 57 degrees. If we had a calculator, we could figure it out. Type that into your calculator, it'll tell you what angle it is. But we don't really necessarily care what the measure of the angle is. We just want the sine of that angle. And so that's what we've done. Any questions here? How are we doing? We doing okay with this? I hope we don't have shocked faces. I can't see anybody. All right, let's take a look at one of the equations. Oh, can we do another graph one? Sure, pick one. Yeah, we can do any of them. While you find one here, I'll maybe just do one of these really quick here. Number 9a, just to kind of give an idea on how to do these problems. 9a, we would subtract the square root 2 on both sides and do 2 cosine x equals negative root 2. Then we can divide by a factor of 2. And the cosine of x is equal to negative root 2 over 2. And so from here on out, we can, from here we can find what the value of x is. We want an angle x whose cosine is negative square root 2 over 2. And if you read the instructions of this problem carefully, it says find all solutions of each of the following equations in the interval from 0 to 2 pi. So, what angles x have a cosine equal to negative square root 2 over 2? Can anybody give us the answer for that? Here's the unit circle. And good. Some people are on top of this here. All right. Pi over 4. Actually, there's a negative here. We want the cosine to be negative. So we're really looking where the first coordinate, the x coordinate, is negative square root 2 over 2. And so 3 pi over 4 is a solution. And some people have already also mentioned 5 pi over 4 is another solution. Yes, good. So, to the student who said pi over 4 and 7 pi over 4, that would be the case if there was no negative here, because both of those are positive square root 2 over square root, or over 2. So those are not the answer for this one. Okay, so these are the two answers, and that's it. Okay. So not too bad either. I mean, you get the way I would do this problem here is to get the trig function by itself. Then it says the cosine of some angle is equal to negative square root 2 over 2. And all you have to do is find which angles have a cosine of that value. Yeah, and so let's take a look at 4a. Yeah, so somebody asked here for this problem here, when do you know when to look for y or x? It depends on which trig function you're looking at. The trig function cosine is going to go with the x coordinate. So that's why we're looking at the x coordinate being negative square root 2 over 2. If you look at 3 pi over 4, we're not paying attention to the y coordinate there. We're paying attention to the x coordinate, negative square root 2 over 2. And when you're looking at sine, the sine is given by the y coordinate. So it depends on if you're looking at cosine or sine. All right, and then somebody asked for 4a, so I'll quickly, try to give a little bit of this. Yeah, so, let's see how much time do we have. Okay, we actually have 1 minute left, so I will do the problem if you want to stick around. Oh, there's a little button on somebody's. I don't know what that means. So just since we have 1 minute left, I'll do the problem afterwards. But yeah, I did want to say, thanks for showing up, and we'll all be in class. I'll be in class on Thursday, handing out the exam. So there is an in-class portion of the exam and an online portion. So be ready, make time at some point to do the online portion, and then of course show up to the in-person part. But yeah, so yeah, thanks for your attention all semester. Sorry that we had to end this way. I couldn't really control getting sick or something, but yeah, I'll see you on Thursday. And if you want to stick around and see 4a, stick around and I'll do it. But as for now, we have about 10 seconds left, so we'll officially end here. So I'll see you on Thursday. And if you want to see 4a, stick around, and I'm just going to start. All right, bye. Yeah, you too. Thank you. Appreciate it. All right. For those who are still here, yeah, if you have a question too, you feel free to type it into the chat and I'll try to answer it. But yeah, I'll be looking at the chat, but I'll go over this problem here. So 4a, again, we want to know, okay, so can you tell us what the amplitude is for this problem? What is the amplitude? Yeah, 3/4. So we know 1, 2, 3, 4. Let's say that the third mark here is 3/4. 1, 2, 3, 4. The third mark downwards is negative 3/4. The amplitude is 3/4. Yep, that's how high and how low the cosine function is going to go. How do we find the period of a cosine function? What's the general formula for the period of a cosine function? Do you remember that? I remember we gave this in class. Good. 2 pi over b. Yep, that's correct. And so the period for this one here is going to be 2 pi over 3. So that's 2 pi over 1 times 3 over pi. The pi's cancel and we get 6. 6 is the period of this function here. So 1, 2, 3, 4, 5, 6. 7, 8, 9, 10, 11, 12. Since it goes all the way up to 12, I'm gonna use 2 units to mark 6. Now, how do we label the horizontal axis? We can calculate the horizontal increment. And that's just the period divided by 4. The period for this is 6. So we'll divide 6 by 4. And you can see that that reduces to 3 halves. So that just means we're going to mark 3 halves. And we, hopefully you've seen by now that there are 4 markings. There's 0 where you start. Then pi over 2 for the basic cosine function, 3 pi over 2, and 2 pi. And so we have, here's the basic structure of the cosine. It starts up at its amplitude, drops down to its 0, drops down further to its minimum, goes back up to its 0, and then goes back up to its maximum to restart the cycle. And so our function looks something like this. Okay. And so you can see that there are 4 sections, 1, 2, 3, 4. So, 4 main kind of sections. And so we'll just add this horizontal increment starting from 0, add 3 halves. And then we add 3 halves again. That gives us 3 halves plus 3 halves is, why am I going blank here? 3 halves plus 3 halves is 6 halves, which is 3. We can also leave it as 6 halves if we wanted to, because then we have to add 3 halves again. So 6 halves plus 3 halves is 9 halves. And then if we add 3 halves again to that, 9 halves plus 3 halves is 12 halves, which is 6. And that's where we get that, this kind of matches up. Our period, it has a length of 6. And now all we have to do is just draw the basic structure of the cosine function, which we have up top. It starts at its maximum at the first, special point. It reaches its 0. Then at the next one, it reaches its minimum. Then it reaches its 0 again, and then it reaches its maximum. It has the same kind of structure as the one above in green. Just like that. And that is the graph of that cosine function. All right. Does that answer your question there? All right, good. All right, does anybody else have a question? Maybe like a general question or anything? I will be uploading this, online. And I actually uploaded all of the lectures or review sessions from the other 3 classes that I have on Mondays and Wednesdays. And so if you go onto my YouTube channel, the last 3 videos that have been uploaded were the other classes. So if you're interested in seeing other problems that other students asked, feel free to watch those. All right, have a good day. See you. Yeah, people are responding here in the chat, so all right. So yeah, feel free to ask a question. If you have one, I'll stay it on for just a few more minutes, and then I'll get off. All right, Isaac and Adrian, you're the last 2 here. So if you have a question, let me know. If not, I know sometimes people step away from the computer, so maybe that's the case here. Can you explain 1 of 11? Oh, sure. Yeah, we did an application, I think similar to this in our class, but yeah, we can look at one of these. Let's look at the sunlight one. That one's nice. These are all, I like both of these problems, but Yeah, if you think about, let's read it here. It says, for a given location, the daily number of sunlight hours fluctuates through the year. Suppose that the number of sunlight hours is given by the following function: d of t, so it's like the daylight, the amount of daylight with respect to time is, so it looks like on average we get 13 hours of sunlight in this location plus 5.2, and then that 5.2 kind of fluctuates depending on which of the days that we are in the 365 days in a year. So remember, cosine takes on values that are, up to 1 and down to -1. And so, we could get 5.2 more hours of sunlight or 5.2 hours less of sunlight, depending on where we are in the year. So it says here, d of t represents the number of hours of sunlight in a day, and t is the number of days after June 21st. Okay, so what is the time for one full cycle of days? Basically, how long is a period here? And how do we, I asked this earlier and a few people responded. You actually responded as well. 2 pi over b, right, is the period. So 2 pi over b. And b in this case, b is equal to 2 pi over 365. So we get 2 pi divided by 2 pi over 365. This is how we calculate one cycle or one period. And so this becomes 2 pi, this is over 1, times 365 over 2 pi. And I don't think it's much of a surprise that it turns out that one cycle here is 365 days. A year, right? It takes 1 year. And yeah, every year the amount of sunlight, kind of fluctuates. Okay, so hopefully that's okay. What is the minimum number of hours of sunlight in a day? What is the minimum number of hours of sunlight in a day? Well, the way that I would say that we could do this one here is by saying, well, 13 plus 5.2. The cosine function, this is the part that's fluctuating. 13 is just a constant number 13. 5.2 itself is a constant. What is fluctuating is the value of cosine, right? What is the minimum value that cosine could take on? Just the cosine function itself, what's the minimum value that it takes on? -1, yeah, that's correct. So if cosine takes on the value -1, then, at some point it will, if you go through one full cycle of cosine, cosine will have to take on the value -1 at some point. And so the value of this function will be 13 minus 5.2, which is, 13 minus 5 is 8, minus 0.2 is 7.8. So 7.8 is the minimum number of hours. Now, we can, is that okay there? Does that make sense? There's a little bit more of a complicated way to do this as well. Okay, so yeah, and I can show you that if you'd like to see it. It's slightly more complicated, but we can use our reasoning here to simplify it this way. And then finally, how many hours of sunlight are there on June 21st each year? Okay, so, well, what's special about June 21st? Remember that T is the number of days after June 21st. So if we're at June 21st, this is really asking for, when T is equal to 0, we are 0 days after June 21st. We're actually at June 21st. So basically it's saying if T equals 0, find D of T. So D of 0, the number of hours of sunlight in on June 21st is equal to 13 plus 5.2 times the cosine of 2 pi over 365 times 0. And so luckily, this just becomes the cosine of 0. The cosine of 0 we know is equal to 1. And so this is just 13 plus 5.2, which is 18.2. And this, it turns out that because cosine starts at its maximum, this is actually the maximum number of hours of daylight in a day, 18.2 it looks like. And this is known as the what is it called? The summer solstice. If you follow, any of that stuff. Yeah, 18.2 is or June 21st is a special day because it's the longest day of the year. So this is actually kind of accurate. It's, it's kind of nice. And so 18.2, that might not be how many hours of sunlight we get here in, Merced, California, but I think there are some places that get more, they all fluctuate, in some way. So it's kind of cool. I like this. All right. Does that does that make sense there? Okay, yeah, no problem. Let's see, and then I got a message here. Can you go over 8B? 8B, sure. Yeah, and then this is the last one that I'll go over here, just because I gotta do something else. But 8B is okay, so it's very similar to 8A, except it has a variable in it. So in 8A, we drew the triangle, we drew the angle, and then labeled the sides, and then found the sine of that triangle, or the sine of that angle. So the cosine inverse is going to be very similar. Oops. The cosine inverse, the cosine inverse is, from the range is from 0 to pi. So it's going to be somewhere in these two quadrants. It turns out that it actually doesn't matter which two quadrants it's in, or which of the two quadrants it's in. We don't know if W is positive or negative. W could be positive 5, in which case it would be, if W is positive, that's adjacent over hypotenuse. The adjacent length, if it's positive, it would go to the right. And then the hypotenuse length is 3. If it was negative, if W was known to be negative 5, let's say, then it would go over here. But it would end up being the same triangle. So it doesn't really make a difference in this case. So let's just assume that it's in quadrant 1. So cosine inverse tells us it's an angle whose adjacent over hypotenuse is W over 3. So I've drawn that there. And we want to find the tangent of that angle. Excuse me. So what's the tangent of this angle? Well, that would be opposite over adjacent. We don't know what the opposite side length is. We don't have an expression for it or anything. So for right now, let's just call it y. And let's solve for it. We can use the Pythagorean theorem here. W squared plus y squared equals 3 squared. So if we subtract W squared on both sides, and we square the 3, y squared equals 9 minus W squared. We can take the square root of both sides, which means we get a plus or minus. But what kind of value is y? Is it positive or is it negative? It's positive, yeah. So we can just use the positive 9 minus W squared. And notice if we had drawn this in quadrant 2, the W would be here, the 3 would be here, that's adjacent over hypotenuse. The Y value would still be positive. So just again mentioning, we could have done it in quadrant 2 if we wanted to, we'd get the exact same thing. And so now we have an expression for Y. Y is just the square root of 9 minus W squared. And so if we want the the tangent of that angle, that's going to be opposite over adjacent. And this is our answer here. Very similar to what we did over here. Except over here, I mean, it's almost exactly the same thing. We did the the Pythagorean theorem, found a missing side length. Instead, we found the hypotenuse because the function we were given was the arc tangent, which is opposite over adjacent. This time we were given the arc cosine, which is adjacent over hypotenuse, which meant the opposite was missing, and so we just had to solve for that one. So it is very similar process there. All right. Yeah, you're welcome. Thank you. You too. All right.
I had a question.
Oh yes. And let me
Um,
let me stop the recording.